Morning, Raj.
Good.
Hello, can you hear me?
Good.
All right. Cool.
Yeah, and evening there in Dallas.
Yeah, no,
Okay. Any doubt, any questions so far?
so far, so good for me.
Okay. How about
Uh,
you, Rituraj?
Uh, I will ask later.
Yeah,
I haven't gone through. I haven't gone through other topics, so that's why.
no problem. Whenever you feel any question, let me know.
Inbound, outbound packet flow.
Uh, Before this, let's go to the one lab where we'll see how the traffic is. We can see like top connections like that from the mm, smart monitor perspective. So you know how to go to the smart monitor. If you go to the logs and monitor, and if you click here, tunnel and user monitoring, it will go to the smart monitor. Uh, smart monitor required a license to have. So just see in your environment if the license available for this. Here you can select this checkbox and install the policy monitoring. and then you'll be having this SmartView monitor in place. Uh, if you come here, if you see the traffic, you will see the top interfaces, top services, uh, the top connection, the one we are, actually talking about. Like yesterday, we were having a question. How we can see all these things, top sources, and if I click OK, it will give you the data about it. So right now it's not facing or getting any data. It's a gateway 1. So we have enabled gateway 2. So let's do this again. Top source, only gateway 2. Let's see. Top source, gateway 2. Okay. So currently we are getting this traffic 192.168.1.10. It's my management server and it's the traffic from the management server. What we're going to do now, we have an attacker. Okay, this is an attacker. What I'm going to do, I'm going to generate traffic from this attacker and we'll try to see if that is getting captured by the firewall. Let me go here. The basic thing I need to run to generate an attack. So right now this attacker is saying the IP address what we is by default have is this one. We need to change that. So if you see the option 0, configure the network setting, so just click 0 and here it will ask you what is the attacker IP address. So let me give it 192.168.1.20 default mask. I'm okay with that. Target machine, I'm going to hit the packet to my gateway 192.168 1.3. That is what my gateway IP address. Yes, default gateway, I'm okay with that. Now we need to select what attack we need to launch. So you select the number 2 option, and here it says what attacks you want: network security category, application integration category. Let's go for the application integration category. So I'm pressing 2. And now what attacks you want to launch? I want all this attack to be run. There's option number 0 and it says randomly for a period of time, only one by one. So I want randomly to be generated this attack. So say number 2, and if I say enter, so attack started, heading to my firewall. This traffic is allowed, that's why it's getting executed. So let's go back to the logs and monitoring. And if you come here, logs and monitoring, very first tab, and if I say today's log, I'm able to see the today's log. See the source 192.168.1.20 and it's hitting the packet to TCP high ports 6500, and if you see the number of packets what are hitting is many. And if you want to see these details from here itself, just come here, there is something called tops and click this here. Let's calculate what are the sources generating more data. Just click to this and you'll be having all those details. And if you want to see what are the top applications are there, so far there's no result, but it's saying that top sources are this. What is the top destination? This guy. top services, TCP high ports, the action, of course, it will be allowed for everything. Accept. Top blades, it's supposed to be firewall. Top origin, gateway 2, right? And same if I want to see from the SmartView monitor, if you come here, if you see, these are the top talkers now. Uh, top sources for the gateway 2, and if you see this 192.168.1.20, you'll be seeing what is the current, you know, percentage of this package and everything. So if you want more detail, just click here, whatever the symbol, it will give you more details in different views. So yesterday, Rutraj, you asked this query how we can locate these details. So this is what very handy option you have to see what is happening, and the application also you can look at from this smart view. I mean this top application things, right? Any question?
Not sure. Yeah, it's good. Not sure. Try this command, see if it works.
Can you share that over the chat here?
Yeah,
I
it's
can
on
put
the
in the.
call messages.
Okay.
You see it?
Yeah, I think it's on another screen. So let me get it.
Oh,
Yeah, so you put it a TCP dump, right?
yeah. See if it helps. I don't know if it works, but
Yeah. It will help, I believe. Let's go to the. So this need to be run from the gateway itself, right?
yeah.
Okay. 192.168.1.3 admin expert mode. Let's try to run this command. Okay, I have to change it. It's 880.
Hmm.
Mm,
Maybe.
FW instead of 0, put all.
Hmm.
So it's listening on those port, and let's try this now. Maybe this will help instead of this. Mm, let's try this. maybe this is not giving a output here. Maybe the situation need to be different.
Mm,
Anyways,
yeah.
but that is how we can, at least we can have an option now to see the stuff from the this thing, smart view monitor and smart logs. If you want to see the top talkers and smart logs, it don't require any license, so it will have to see the stuff from there. Uh, yes. So I'm just closing this now. Okay. Um, yes.
All right.
Uh, so inbound outbound packet flow. Uh, the kernel which resides beneath the operating system, it has two parts. Uh, one is inbound, like the packet which is coming in inbound direction, and the one is outbound, the packet which are going out. So they call it like a logical part of the kernel, which are representing the process of a packet coming in and out from the firewall, respectively. Each part of the kernel act as independent and does not assume that a packet was inspected or processed by the other. So the inbound direction is complete one sort of inspection. So all whatever you're seeing there from 0 to 14, it's all get inspected. Likewise, the other side, the outbound part, you know. So because of that, you will see the some functionality is implemented on the both the side, and some functionality is implemented on only the inbound direction, and some is implemented on the outbound direction. Uh, each direction has its own order, chain of model, packet processing handling. So this handling, or they call it like a handler, decides whether to continue, terminate, or hold the processing of the packets based on the this stages. Uh, whatever the inspection is getting performed, it's on a virtual defragmented packets. So the packet need to be defragmented to have those inspection to be performed. The inspection process does expect that the packet is in the outbound direction that hasn't visited to the inbound direction. Uh, like of course you have this IP spoofing for that. It has to be verify the details as per that. So from whenever the packet comes from the NIC, it goes to the inbound direction of your kernel, and it verifies all these things. And similarly, once that is has done, it move to the outbound direction, and again these are the things which is listed as the outbound direction. All these things get verified. Then uh, this is uh, the chain, how the things looks, and this is how you like to read. So, for example, if I go to this uh, firewall and if I run the command fwctl chain, uh, it will give you the same output, the one we are just talking about, inbound direction chain and outbound direction chain. Okay, and depending on the things you enabled, you will be able to see the packet flow accordingly. Like these are the things which are getting verified each and every time, and the packet hits to the firewall. So let me take the pen here, and we'll discuss on this. So every part of this has a specific meaning. Okay, so if you see this, the numbers starts uh, from this 0 to 13, like that. These numbers, uh, they call it model location, model location in the chain. Okay, or in simple word you can say serial number. Okay, then there is this number which is in hexadecimal format. These numbers, they call it like a chain position. Okay, then these are the numbers again which are bracket, that is called a functional pointer. And at the last, if you see these numbers like this, uh, they call it like a mode in which the chain is applying. So looking at these details, you can now able to read the things. So this is your serial number, then this is your chain position. These are the your mode in which the chain runs. So basically, mode in which the chain run have a different meanings. So if you locate somewhere like a number one, say for this 0 0 0 0 0 all ones, okay, it's a binary one format. Uh, we call it like a stateful mode. Okay, if you locate anything like 0 0 0 0 and 2, right now I don't see that 2. That 2 is called wire mode. So there is a feature called wired mode. If you enable that, you will see number 2 here. But right now that feature is not enabled. That's why we are not seeing anything like number 2 or number 2. And there is something called number 3, as you can see here. That number 3 indicates your all packets. Okay, and there is something called all FFFFF. It is also like all packets. Okay, it's identical like number 3, this one. So if you read this thing, uh, all 0 comes under secure Excel inbound. That means the stateful mode is enabled and the connection tables capturing the details. So whenever you will see all zeros, you will see the secure Excel related things, stateless verification, or sorry, stateful inspection related things. So locate all the zeros, everything you will see like secure Excel kind of things. And secure Excel we have the SND which capture the statefulness, right? Likewise, wired mode we don't have right now, so let's skip it. Number 3 is all about your packets, which are offloaded like that, or FFF, or is again all about your packets. You know what is what processing is happening on your packets. So this is how you can read this chain model, okay? And this is the one direction, which is inbound direction. This is one direction, which is outbound direction. Important point, which here we need to locate, but right now we don't have that enabled, which we call VPNs. So if the VPN enabled, here one more packet path will be added, which is called encryption. So depends like how the packet is traveling. You will see here one encryption kind of packet, and at the other side one is as a decryption kind of packet. So which indicates that the packets uh, where it's supposed to be increased is getting encrypted, and the packet which is supposed to get decrypted is getting decrypted. So whenever we talk about a packet flow, uh, we always talk about this. This is the real stuff. The one we generally talk first happen, this thing, then matting, then this, then this. That is what the overview. But if you look into this, this is how actually the packet is processing. These are the things, and depending on the blades you enable, the things popped up here, right? Any questions so far?
Are these the flags which are enabled in the kernel after the traffic gets past the NIC?
Mm-hmm. Right. So if you see, these are the flags, or in other word, we call it module. So FW module, like that. C pass module. We'll be seeing these modules in a bit, but don't call it like a flag. These are the modules.
So these are the
What do you
modules.
mean by modules? Modules are the functionality of the firewall. The firewall has a firewalling functionality. We call it FW, right? Like that.
So these are
Secure Excel, yeah, secure Excel functionality. We call it secure Excel.
these are modules which are turned on in the kernel when the traffic
Right.
goes.
For the debugging purpose.
Got
We'll be doing that in a bit, right? Let me clear the screen. Let's go to the next slide now. So you'll be having these details with you, for your reference later on. Now this is how the connection looks, connection table format. So each new packet is recorded in the table in all available entries of the firewall. One entry was made on each new connections. Each packet had to go through the connection table several times to verify all the available types of the connections. So whenever the new packets hits to the firewall, we know the state of that packet is get captured, right? It is stored into the connection table, and this is how the format is. The connection table format we'll be seeing from the gateway itself. But for now, just understand this theory. Uh, if you look closely on this slide, there is a symbolic link which provide six tuples of the connection what we want to pass, and there is an indication which with help of the arrows, uh, these arrows, such sort of arrows, uh, which is actually the pointer to the tuples of the real entry in the connection table. So basically, we have six tuple here. I'm calling as a tuple. You can call it anything like the six attributes like that. So as we know, whenever we call it like static inspection, the things like source IP, destination IP, source port, destination ports, protocol, one, two, three, four, five, and sequence number like that. These things is getting captured. So this is all about that only. Okay. This important indication. There's something called 0 and 1. If you notice, there is a 0 and there is a 1. Uh, the direction can either be 0 or 1. So 0 is for your inbound direction. Okay. So whenever you see 0 in a connection table, it's your inbound direction. Whenever you see 1 is your outbound direction. Okay. So the if you see the first entry here, this entry hold all of the relevant information for the traffic, such as state, sequence number, matching rule, and so on. Uh, let's jump to the lab and see this stuff in real time. But any questions so far on this?
I'll see it in the lab. Okay.
Uh, Okay. Uh, if you run the command fw tab, okay, so this is the command which we use to see the connection table entries, see the connection tables, whatever tables we have with the firewall, right? We use this command for that. So we can do either two things. We can capture the details into any output file, uh, or we can see over here. So if you see, if I just type the command fw tab -s, it will give me all the tables what we have for the kernel and what things are going on with this. Please note down this command. It is important command. And if you just want to see what other things is happening on this, there's a big list. I mean, these are all your tables, and there are all their values. So currently these are the connection going on. This is the pick connection what the firewall picked up, like that. So let me clear up the screen here.
Are these the database tables?
Yeah, no, it's a kernel tables, whatever we have into the firewall. Let's run this command again. AW tab -t connections, and I want this to be run for every 2 seconds. Oh, sorry, I want it to be run 2 times. So if you see, this is how the entries is present into the connection table, and I don't think so. This is a human readable format. And if you want to make this human readable format, just use the option called -f, right? So same thing which is presented here with the decimal, or sorry, with the hex format, will be saying into the human readable format. Use this -f, okay? And this is how the connections tables look like and the entries are stored. So this is the IP address and its attributes details, right? Let's do um, let's do something for the core Excel, okay? So as we have the core Excel enabled into these gateways, so you can run the command like fw tab -t gate number 858 v f. Okay, these are a lot of entries. Let's have the say 5 entries, right? So if you see here, there is something called source. Let me look at that. Mm, 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 mm. Okay, let me do this again. Instead of 5 entries, let's have all the entries. So if you see something like this, destination 1, like this, assume these are your firewall workers. Let me have this format without having the filtering place. So we'll be getting desired output. Instead of F, just press V. And if you see, you will be seeing the same thing like this. FW worker 0, and what is happening with that worker 0, which worker is storing what data, like that. And if you want to format it in a human readable format, just use this F -F, and try to look like this. This is what I understood. So
Not tell which
yes,
firewall worker is it.
So this is what you can see.
Oh,
So you know that's -1, -2, right? This is what a firewall worker is.
oh, got it.
But I haven't given a time stamp to this because sometimes I can see source -1, sometimes I see guest -1. But when I compare that with the output of that, the ASCII format, I can see or I can match up that this is what the firewall worker.
Right.
And these are the details on this, you know, and you can read it like a source IP address, destination IP address, destination protocol, which protocol family it is, the direction, you know. As I said, the one indicates what, which direction, inbound or outbound?
Outbound.
Outbound, right? So this is flow for the outbound direction, and if you see something like zero, it's inbound direction.
So this tracks everything which is coming in and out of the firewall.
Yes,
All right. Okay.
but it's very deeper level if you want to look at the connection table format. And a connection level, which table is storing what connection, like that. If you want to go in that deeper, you can use these commands, right?
But this is not where the decision is made, where the
This
firewall
is
will.
where the decision makes, okay?
Uh,
And you know what? Uh, how the connection table works,
no.
it capture everything,
Mm-hmm.
For example, this is your connection table. So it has this entries: source IP,
Mm-hmm.
destination IP, source port, destination port, protocol, sequence number, like that, six tuple. So consider this is my big picture, and this is my firewall, and this is one of the connection table we have. We have the policy here, right? We allow the source, destination, source is this, destination is this, applications is this, services this, accept, something like that. Whenever the packet comes, uh, so these are the we have various stages here. So you have these, say SND, you have your core Excel, right? The firewalling path. So whenever the packet comes, it will goes into all these pages, and these details get captured into this connection table. That's what I we said. So consider this connection table is for the SND, right? So capturing the only details like source application, like the source port, destination port, and protocol will serve the purpose for every time. What I mean to ask, how this SND know that the connection is allowed or denied, right? Because it was having only these details like source IP, destination IP, source port, destination port, protocol, sequence number. Based on this, how he can decide whether the packet is allowed, and instead of going to the next level looking for the firewall and all this process, it just process the packet at this level, and it take a decision whether he need to process the packet or drop the packet, whatever it is. How he knows these things are allowed or not? Any idea on this, guys? We haven't touched this part, so that's why I'm touching now.
No clue, but it's important.
Yeah. How about you, Raj?
Yeah, not an idea. Maybe it should be compared with the database. Maybe.
Yeah. So uh, the state of the firewalling like this. you know, is also getting stored into this sort of tables, connection tables. Are you believing me or not?
So the firewall rules are stored in connection tables.
Yes, but not actual rules,
Mm-hmm.
but the status. For example, if the packet coming
Mm-hmm.
and the packet captured like, okay, this is source, this is destination, this is protocol, and it is allowed or denied, okay,
Mm-hmm.
that state is stored into this connection table. And if you want to validate that, I have one command for you guys. Let me clear it out. I think nobody touched this deeper, but I want you guys to see this stuff. So let me run this command. Right. I am getting this data from the connection table. If you see, so rule number 0 is saying that this is my source, this is my destination, this is my port, okay, like that. So these are all the entries which are currently allowed. Let me copy paste this command over a chat for you guys so that you will be having this handy with you. Oh, sorry, what is part capture? We have the command. The output is get captured. The command is this one. So here just you have to check which details you need to see. So now consider we done for that IPS attacker. What was the IPS attacker IP? 20. So right now we don't have anything for that IP address. But whatever the recently going on, you will be getting this. Now to prove that the connection table have a timer, I just want to run this. Right now there is a IPS attacker, we run. Remember IP address 20 we have given, but I don't see any entry now on this. But what if I, test it lively and see if the table will get the details for this IPS attacker if it's this simply running. You following me or not?
So
Yes, no.
so basically the IPS. Oh, sorry. Go ahead.
What I'm trying to present here, I'm trying to present that connection table have the buffer. That's it.
What if it
Right
doesn't
now,
know? Like it doesn't know anything about the IPS, so you won't have any record of it.
yeah. Only thing is that see when we talk about the DDoS attack, uh, some attacks the connection table sometimes the buffer get full, because of the lot of connections. But Firewall has its own intelligence to keep that connection for certain time. I haven't touched that. I'm just freshly doing this. This thought come in my mind that let's see if the buffer allocation happens. Right now, if you see this uh, IP address 168.1.20, there is a no rule or no connection, no entry there present as compared to the as compared with the allowing part of it. Although we have run this before, that we try to do the attack from this IP address to the firewall, and the state got captured. I just wanted to check that if I rerun this thing, I can get some rules for this or not. Let me see 0, 192, 168, 1.20 is my attacker IP, I guess. I don't want to deposit that. This is my gateway. I want to run, say, second, 10, second, 0. Let's see. I don't know whether it will show that details or not, but let's run this. See, so whatever the latest things happening, you can see that into this. So now it's proved that connection table store all the details. So if tomorrow, if you suspect that things are not working well for some IP addresses, to check the connection table whether what is happening on that. It's very deep. If you want to go in that deep, you can go like this way, right?
Interesting.
I haven't touched this part. This is the first time I'm looking into this thing. So it's new learning for me also. Let me stop this guy. All right. Any questions so far? So take a 5 minutes break, digest the thing, and then we'll touch to the new topic. The connection table things got over, right? I think it's pretty clear how we can look in the things, right? At least now. Later on, if you have any question, you come back to me. All right.
Sure.
Take a 5 minutes break, and we'll talk on the packet inspection flow for the kernel from the gateway side.
All right.
I'm back. Let me know